So I was discussing about what if your variables or the relationship between IV and DV is not proved to be linear, then what to do? If the relationship is not seems to be linear, you need to transform the variable by taking the log, or you can take the square root, or you can also create a reciprocal of your target variable. These are the methods which make your non-linear variables into linear variables, and then after transforming, if you check the uh, linearity of those variable, it will become linear. You can also add the interaction terms by adding mediation or moderation. You can also make some non-linear effects into linear one. So this is the second technique. There are some other techniques you can consider for in case of violation of your assumptions. Like you can use the non-parametric approach. There are some non-parametric approach which you can apply, like non-parametric regression method, or kernel regression or local regression. There are some methods which you can apply in case your variable seems to be nonlinear. You can also use the categorical variable. Sometimes we are checking the linearity between continuous variable and categorical variable. So we need to create some categories. If the relationship is inherently categorical, we need to create the categories. So consider converting the variable into dummy variable and including them in the model. So I will let you know tomorrow while discussing different cases of regression. I will let you know how the dummy variables are created and how you can create different categories of variables. You can also check for data for errors. There might be it might be possible that your data have some outliers or some missing data, or there may be have some data entry errors. So you need to check the data for errors, and sometimes your sample size is very small, so you need to collect more data in order to increase the cases. Someone is asking, okay, someone is sharing, like Michael is sharing the window. Very well done, Michael. I see your results. Yes, this is perfectly linear. This is perfectly and positively linear. This is very well. And this is the relationship between total marks and GPA. And this is perfectly and positively linear and very strongly linear. Yes. All right. If someone have checked the relationship between percentage and GPA, please let me know. Or you can also share, like Michael has shared, the screenshot in chat bot. You can also share. All right. I was letting you know the remedies in case linearity assumption is violated. Now, let's assume for the second consideration, which is normality of residue. It is the second assumption. In case of first assumption, I let you know that there should be a linear relationship between your IV and DV. These were the basically the basic assumptions. The first assumption was there should be a linear relationship between DV and IV. If the assumption is violated, we may have some remedies. Our second assumption is the residual or error should follow a normal probability distribution. It means whenever you are going to test your data in respect to normality, you basically need to check the normality of your residuals or errors. So, what are the error or what are the residuals? First, you need to consider it. Some of you may not be aware with the idea or with the concept of residual, that what are the residuals. So at first I would like to let you know what is the concept of residue. Whenever we check the linearity of our data, we may have a reference line and a best fit line, and we may have some points which are away from the reference line, or which you can find away from the reference line. So these are basically the error, the gap between your actual values or your measured values and your predicted values. So this red line is basically the predicted value. This red line is indicating the predicted line. So the values which are appearing on this red line would be considered as a predicted values, and the values which are appearing uh, just above or just below this red line would be considered as a error, or the gap between those points and between the predicted lines would be considered as a error or residue. So how can we basically define the term residual? We need to understand that it is the gap between predicted points and your estimated points. So recall, the residual is the difference between the measured value of y and the predicted value of y. Predicted means what we have estimated. It means the red line. The reference line or predicted line is considered your red line. So whenever you compare your actual data means the data you have provided in your data set. So whenever you are comparing your actual data with your predicted data, there may be some difference between actual and predicted data, and that difference is considered as a residual. So you need to capture the residual or the error or the gap for every observation in your data set. So the residual should be normally distributed. This assumption is more critical with smaller sample size. Always remember that whenever you have at least 30 observations, you may consider your data to be normally distributed. But if your data is smaller than 30 observations, you need to check the normality assumption. So in every situation, you don't need to check the normality. If your data has at least 30 observation or more than 30 observation, you don't need to check the normality. But if your data has less than 30 observation, you need to check the normality. So this is the important point you need to consider. So why normality testing is needed? Technically, normality is necessary only for hypothesis test to be valid. So whenever we are going to test our hypothesis that whether this independent variable have a positive impact on our dependent variable, or whether this independent variable have a negative impact on our dependent variable, and so on, we are going to test the hypothesis. So whenever we need to test the hypothesis, we may need to check whether our data is normal or not. So estimation of the coefficient only requires that the error be identically and independently distributed. Some researchers believe that linear regression requires that outcome or dependent variable and your independent variable be normally distributed. Some researchers require, but majority of researchers are agree that you need to check the normality of your residues. So we need to clarify this issue. In actuality, it is the residual that need to be normally distributed. In fact, the residual need to be normal only for the t-test to be valid. So if your residuals are normal, your t-tests are valid. If your residuals are not normal, we may consider that your t-test or t-value are not valid. So you need to check the residual, or you need to check the normality of the residual of the data. So how can we decide that our data is normal? There are two ways you can decide using your data. There is a graphical way and there is a non-graphical way. Using the graphical way, you can have a probability plot like a bell-shaped curve. If you can, if you can find a bell-shaped curve of your residuals, you may consider it as a normal probability assumption. So whenever you find the bell-shaped curve in a histogram of your residual, you can consider it a normal curve, or you can consider that your residuals are normal and your assumption is met. The second way is to consider the normality QQ plot. Whenever You find out the normality QQ plot, and you find that the dots are along with the reference line. You can consider your data is normal. But if the dots are away from your reference line, you can consider that your data is not normal. So in case of graphical method, you have two options. One is histogram and the second is normal QQ plot. So here I have also provided the text related to this. SPSS provide histogram and normal probability plots of residues. You can also use the statistical test like the Shapiro-Wilk test. This is non-graphical method. If you are interested to find out, and if you can not identify any pattern, or you cannot be able to decide whether the graphical pictures are showing the linear relationship or not, you can directly check the Shapiro-Wilk test. That will provide a value of significance. If the p-value of the Shapiro-Wilk test is less than 0.05, we may consider that our test is not normal. But if the value of Shapiro-Wilk test is greater than 0.05, we consider that our residuals are normal. So, however, keep in mind that with larger sample size, the central limit theorem often mitigates the importance of normality. It means if your data set is greater than 30 observation, you can skip the normality procedure, because uh, the statistical assumptions require that your data need to be at least 30 observations. So if your data contains at least 30 observation, you don't need to check the normality. But if your data is small and it contains less than 30 observation, you need to check the normality. So there are three ways. One way is histogram, second one is normal QQ plot, and the third way is Shapiro-Wilk test. So graphical method, the graphical method contains the histogram and normal PP plot that I have told you earlier. So how you can run this procedure? How can you apply the first method, which is histogram method? You go to analyze, you go to regression, then you go to linear, you enter your dependent variable and independent variable there. Then in the linear regression dialog box, go to Save tab. Then you check the box for unstandardized and standardized residuals. Then you click Continue, and then you click OK to run the analysis. Then you go to the histogram tab, go to the graph legacy dialog box, histogram, choose the variable that represent the residues. This is basically very important consideration, that as a variable you are taking residues, and you will create the residue using the previous procedure that I have explained in save residue procedure. So in this process, you will create the residue, and that residue will be used in the third step. So you will click OK to generate the histogram. Examine the histogram for a bell-shaped curve, like I have previously told you. If your curve is look like this, like a bell shape, it means your residues are normal. But if your curve is not bell-shaped, you can conclude that your residues are not normal. So this is the first procedure that you can apply over there. So let us check the procedure using our screenshots. So you need to go to the analyze, you need to go to regression, linear, and you need to check out for your dependent variable and your independent variable, which I have already used. For example, one final term marks as a dependent variable and GPA as an independent variable. Then you need to click on the save button. You can see on the right side there is a save button, but you need to find out your dependent and independent variable, and then you need to click save button. When you click the save button, you will find another window like this, and you can see there is a box containing the predicted values and residual values. You need to check unstandardized and standardized residual from this window, and then you need to click the continue button. So whenever you click the continue button, You will again return to the previous window where you need to click the OK button, and then you will find Nova output like this, where you can also see the residual statistic. But first, you need to check whether your residuals has been generated or not. In order to see it, you need to check the data view of your data set, and you will see that there are two columns uh, that were appeared after this whole process, and the first column would be considered as unstandardized residue, while the second column would be considered as a standardized residue. So RES1 is basically unstandardized residue, while the ZRE1 is standardized residue. So as we have selected the standardized and unstandardized residue from our previous process, so it will generate the residuals of your data. So what we will do, we will go towards the next step. The next step is to move towards the graph. You will select the legacy dialog box, then you will select the histogram over here. After checking the histogram button, you will see you need to put a variable box. You can put your unstandardized residue over here from your variable list. Then you need to click OK button, and it will generate a graph like this. And you need also you need to check the display normal curve button also. So whenever you check this button, you click OK, and you will see a graph like this, and you can see here there is a bell curve rising over here. It means your data is normal. You can apply the same procedure with standardized residue. This is the procedure with unstandardized residue. You can apply the same procedure with standardized residue, and you will find again that there is a normal curve over here, and we can conclude that our residues are approximately normally distributed, because there is a bell-shaped curve over here. So you can apply this procedure over here. We can run this procedure on our same data set. So how can we run this procedure? It is very simple procedure. At first, you need to go to analyze button, then you need to go to the regression, then you need to click linear. You need to put your dependent variable over here, which is total marks, as a first example. Then you need to put GPA over independent variable. Then after putting it, you need to click on save button, and you will find a box like this, where you need to check in the residual area unstandardized and standardized. It will generate two columns. One is for unstandardized residue, and one is for standardized residue. So after checking it, you need to click continue button, and then you need to click OK button, and you will find an output like this, where you will find a table with residual statistics. But the thing you need to verify is you need to check your data view. You need to go to your data set, and you need to check your data view. You can find out here that two columns are generated. The first one is RES1, and second one is ZRE1. The RES1 is basically unstandardized residual basically column, and ZRE1 is basically the standardized residual value column. So what we need to do, our next step is, if you remember the procedure, I have told you that after creating your residual, you need to go to histogram, from where you need to go to the graph legacy dialog box, and then you need to check the histogram, and then you need to put your residual over here as a variable, and you need to click OK button. So what we need to do, we need to go to the graph button. We need to click on the legacy dialog box, and then we need to go to the histogram. This option is the last one over here. You need to click it, you need to put here your standardized or unstandardized residual. Most of the researcher prefer that you need to put the standardized residual over here. So you need to click the standardized residual. You need to put it over here. You need to check this button, display normal curve, because it will create the bell-shaped curve in your histogram. So you need to click on it and you need to click OK, and you will find a graph like this. So we can conclude here that there is approximately normal distribution. There is approximately normal distribution uh, of our residues. But remember, there are other procedure from where we can verify whether this distribution is normal or not. We can, if we are confused and we are still unsure whether we consider it a normal or not, we can go further. We can proceed further steps. The next step is you need to create a normal QQ plot. So how can you create it? First, you need to understand the whole procedure from here. I will elaborate. This is the second graphical method of testing the normality. It is QQ plot or normal QQ plot. So how can you create normal QQ plot in order to test the normality of your residuals? You need to go to analyze descriptive statistics. Then you need to click on explore button. You choose the variable representing the standardized residue, the one you have created already. So you need to choose the standardized residue and put it into the dependent list. Then you click the plot button, select normality plot with testes, click continue, click OK to generate the QQ plot. If the points on QQ plot closely follow a straight line, it means if the points are on the straight line, it suggests normality. But if the points are away from the straight line, you can consider that your data is not normal. If the points on the QQ plot to closely follow a straight line, especially in the center of the plot, you need to check the center of the plot. It suggests that the data is approximately normally distributed. Any deviation from the straight line may indicate departure from normality. So let's see how this procedure is applied. I have included the screenshot in order for your understanding. You need to go to analyze button. You need to click on the descriptive statistics. Then you need to click on explore button, and then what you will find when you click the explore button, you need to put your standardized residual, standardized, not unstandardized. You need to put your standardized residual into dependent list. Then you need to click on plot button. Here is the plot button on the right side. You need to click it. Then another window or another box will appear. From here, you need to check the normality plot with test. This box, you need to check this box, and you need to click continue. And after you click the continue, you will see the normal QQ plot like this. So you need to check from the middle of your data. You can see that majority of the points in the middle of the data are basically on the straight line. So we can conclude here that our residuals are approximately normal. Approximately, you cannot claim that it is perfectly normal. You can say that it is approximately normal. So there is a third test that you can apply. So how can you do this step? I will let you know. You go to the analyze button. You go to the descriptive. You go to the explore button. You will find a box like this. You need to select your standardized residual. You need to put it in the dependent list. You need to go to the plot button. You need to check normality plot with test, and then you need to click continue. You need to click OK button, and you will find some statistic like this, where you need to find out your normal QQ plot. So here it is. This is normal QQ plot of standardized residue. as majority of the values from the middle or from the center of this line are along your straight line. So we can say that the residual of our data are approximately normal. The third method that you can identify that you can use to identify the normality of your data is basically the non-graphical method, and you can use it using regression, linear. You can go to the same procedure that we have previously applied for dependent or independent variable using linearity of our data. And, we have put over here uh, the plot button. You can put here uh, your data, and you need to check basically the histogram and normal probability plot over here. You just need to check these two options, histogram and normal probability plot, and you need to click continue, and you can find out both table, uh, like histogram table and like normal pp plot in the same estimations. So I have computed it differently. You can compute it in a combined way using this procedure. So the third procedure, what is the third procedure? That is non-graphical method. The third procedure is that you need to see the Shapiro-Wilk test or uh, Kolmogorov semi uh, Smirnov test. So, what are the difference between both of these tests? Uh, the first one, Shapiro-Wilk test, is recommended when you have a smaller sample size, less than 50 or less than 200. But if you have a larger sample size greater than 200, you need to see the Kolmogorov Smirnov test. So which one to choose if you need to choose among both of them? First consideration is the sample size. So for a smaller sample size, the Shapiro-Wilk test is often recommended due to its higher power in detecting departure from normality. For larger sample, you need to check the second one. So how we can apply this procedure? How can we test non-graphical procedure for testing the normality of the data? So here it comes, the SPSS procedure. You need to go to the descriptives to analyze descriptive, and you need to select explore button, and then the next window will appear. You need to check the histogram stem and leaf display normality. You need to click the continue button, which we have previously done in our previous example, and you will find out Kolmogorov, Saraminov, and SIG of Shapiro-Wilk test, and you will find out their SIG value. If the p-value is greater than 0.05, it suggests that residual are normally distributed. So it was our criteria that we were using during our mean comparison method when we were using the sample KS test. The same criteria was there. If the p value or the sig value is greater than 0.05, it suggests that data is normal. But here in this case, the residuals are normal. So it is basically the test that we would use for testing the normality. So it is basically available whenever you run the previous procedure. You can see over here, but in this case, the only thing that we need to change over here, the thing that we need to change over here is basically the process. So what is the process? Previously, we have used the previously we have basically used uh, the residual value, but now using this procedure we need to put our dependent and independent variable. So how can we do it? We need to go to the analysis button. We go to the descriptive statistics, we go to the explore button, and we need to put out the standardized residual, because you need to use the standardized residual value when you need to have normal QQ plot, like I have previously done. If you need to find out the normal QQ plot, then you need to use basically uh, this variable standardized residual. But when we need to find out the Shapiro-Wilkins test for normality, we need to put in the dependent list the dependent variable. The dependent variable in our case is the total marks, or sorry, final marks are the dependent variable, and GPA is our independent variable as a factor list. So we go to the plot and we will check the stem and leaf, the histogram, normal probability plot is already selected, and we need to click the continue button, and then we need to click the OK button. We need to see the other options also. No, this option is not required, and this option is not required. Only you need to click over here the histogram, normality, and summary. So you need to click OK button, and you will find out the values like this test of normality. So here we can conclude. Just a minute. Yes, it is generating right now. I was considering that it was generated. It is generating. So I need to find out my required test from here. Just a minute. It's generating so many values. I need to check whether I have put it. All right. I need to remove these two columns because I doesn't need them. I need to clear them. I need to run the procedure again. Explore, dependent list, independent list, go to the plot. You need not to check anyone from here. Just normality plot with test. You need to click continue. You need to click OK button and just wait for a while. The output will be generated soon, and we will see our required test. We have omitted some of the values. It's generating again and again. It doesn't require it. I will see what is happening on my side, but let me conclude this. If the output will appear, it will appear like this. A table will be generated like this, and you will need to see Shapiro will test result. If it is greater than 0.05, it means that normality is assumed or your normality assumption is fulfilled. So you need to conclude like this. The next is what are the remedies in case of violation of normality assumption? If normality assumption is violated, what we need to do? The first thing that we can do is the transformation of our data. We can apply the mathematical transformation to our dependent variable or our independent variable to achieve more normal distribution of residual. You can consider log of your dv or iv. You can consider the square root of your dv or iv, or you can inverse the transformation. You can also use the weighted least square regression method. It is a regression method which is available in case your data is not normal. You can use the least square method. It will provide the efficient estimators. You can also use the robust regression technique where you can decrease the maximum number of error from your estimations. You can also use the non-parametric methods, which is basically reliable for non-normal method. You can also bootstrap your data like using the smart PLS like MS. They are helpful for bootstrapping the data. If your data is non-parametric or non-linear or not normal, you can apply the bootstrapping technique using smart PLS or MS, and you can estimate your coefficients in a reliable way, in an efficient way. You can also check whether there are outliers in your data, because sometimes due to outlier your data becomes not normal. So if there are outlier, you need to make them correct. You need to remove them, or you need to rectify them in order to make your variables having the normality assumption. You can also explore the interaction effect. You can add the mediation or moderation impact between your IV and DV in order to have the normality of the data. You can evaluate the model specification. Sometimes the model is misspecified, especially in case of time series data or in case of panel data. There are a lot of different models, and you need to check whether your data requires some changes, some modification, or there may be some specific assumptions that you need to check before finalizing which type of model you need to apply. So in case your data is time series, your data is panel, you need to check which specific method of specification or model specification you need to apply over here. Then you need to check residual diagnostic. You need to check the diagnostic plot, statistical test in order to address why your data is not normal. You can also check for non-normality tolerant tests. They are very helpful in applying the regression analysis. So the third assumption is basically the independence of error of residual. But before applying this assumption, I would request all of you to please check the normality assumption on the previous combination of your data set. We have example one, and I have checked the final term marks with GPA for checking the normality of the data. You can check total marks as a dependent variable and GP as an independent variable in order to check whether your residuals are normal or not. You have three procedures. The first procedure is basically the histogram procedure. The second procedure is basically uh, the normal QQ plot, and third procedure is basically the Shapiro-Wilson test. So you can apply the procedure, because after 1 minute the meeting will be ended, and you need to start the meeting using the same link. So we have 2 to 3 minutes. You can check the second assumption using this data, total marks and GPA, or percentage of GPA. So please try this so we can proceed further. While if you have any question, you may ask in between before ending this meeting. We will proceed further